All right, guys, this is actually me today on February 16th in 2023, not a video from the past. Here's the deal. We're going to go through the 614 examples from class problems that are on your handout. They need to be done on your handout, or I will know that you skipped this video, didn't actually watch it and engage with it. And guys, you should have some kind of expression mat out because we're going to use this at least for problem 35 to solidify an idea that we haven't really done yet. And it comes down to this question where Jerry and Ken are working on this inequality, which I know like we mainly covered that yesterday in a video from last year. And I get that, but like we're going to solidify these things today because I still don't feel great. I can't teach all day long and expect to make it all day. So I'm doing a little flipped classroom version of teaching. Sorry if this reminds you of when we were in COVID and you weren't quite with your teacher. But also we want to work on doing what we're supposed to do, like when we're given a set of tasks to complete, because I heard that yesterday was, okay for some of us and not quite so good for other ones. So we want to get this mat out, or the one on your desk on your paper, and you want your 614 paper out, and we're going to build what Jerry and Ken have. Now, I don't quite have the right symbol yet, but I can make it. So I have the less than symbol, but if you check your handout about what symbol is this is less than or equal to. So I'm going to go ahead and create a less than or equal to symbol that also has the bar beneath it that shows us that we are allowed to be equal. So 3x, 3x's, and a negative 1. So make sure you ask yourself, which side should I be using? If it's a negative 1, we should be using the red side, right? Is less than or equal to 2x. So if we remember the things that we're allowed to do on both sides of an equation or an expression or a inequality, like what we have here, it's not an equation because it's not equal, right? It's an inequality. We can either remove the same things from both sides or like do the same thing, right? We could actually do anything we want as long as we do it to both sides. Or, well, we'll get to the or when we get there. So first things first, I think all of us should recognize we could remove an x from both sides, but we could actually do that twice. And we're going to start to practice writing this process out. So what we want to do on our paper is show that we removed two x's from both sides. And I like to do that using my red pen. Up to you guys if you just do that in pencil or what, but we should write it down so that we know what we've done. So now, after I do that, what we have is just, well, we still have a 1x over there, so I'm going to need to write that. So we have 1x, and you could just write x, is now less than or equal to 0. I'll zoom in on that real quick. So I showed my minus 2x from both sides, and now I show what I have left. But since we have nothing on this side, that creates this weird relationship up here. And one thing that I showed to at least one of the Math 7 classes, but I'm not sure that I showed it to both, is with the we're allowed to do whatever we want as long as we do it to both sides, that brings in a cool opportunity of if I want to get rid of this negative 1, I know that if I had a positive 1, I could get rid of it. So just like taking things off of our mats, we're allowed to bring things onto our mat as long as we do the same to both sides. So if I bring in a positive 1 on both sides, what that's actually going to do is cancel out this negative 1. So this can be gotten rid of while this 1 just stays there because I just brought it into my situation. How I show that algebraically, like how I write that out, is we physically added 1 to both sides. And well, so using red might make us confuse that it's a positive. So I'm going to go ahead and use green here. So we physically brought a positive 1 into both sides. It canceled out the negative 1 over here and left us with 1x, which is what we're trying to solve for, is less than or equal to positive 1. Now this comes back to needing to graph these inequalities, which if you tried your 613 homework, you should already be practicing graphing some inequalities. So if you haven't tried that homework, you probably should. How do we graph x is less than or equal to 1? Well, first we need to draw our number line. And maybe I'll zoom down in here a little bit. So then, what numbers matter here? I'm going to make this nice and easy for you. I know I said the bad word. So the only number that matters here is the number being referenced across our single x, right? We got to get this down to a single x, but we're there. We got just one x. So the number being referenced on the other side is positive 1. That's our boundary point, right? And we're going to talk about boundary point down here. But 1 is now our boundary point, and we always put a big old circle around that boundary point so we can obviously show whether it's shaded in or empty. Now I'm going to use a different color just to help like exemplify what I'm shading. If x is less than 1, I would need to shade to the less than 1 side. And if I don't want to go all the way, I can draw an arrow on the end of my shading to say, hey, that shading keeps going. But then if x is allowed to be equal to 1, I also shade in the boundary point. So this question down here about when is the boundary point included? Well, when we are allowed to be equal to that number. And we'll practice 36 and 37 to practice through those. But this shows our shading is actually representing what x is allowed to be. X is allowed to be 1. X is allowed to be less than 1. So x could be 0. X could be negative 1. X could be negative 7,402. Right? Like it could be anything on this side of positive 1. So if I come down here to, and I'm going to start drawing my number lines in black probably just to make life a bit easier. X, double check that you know what that symbol is. X is less than negative 1.5. So we draw our number line. We make our boundary point, which here is negative 1.5. On that, we draw the open circle, and then we decide, does it get shaded or does it stay open? So since we're just being told x is less than, and we don't have an or equal to symbol, since we don't have the or equal to, that line beneath the symbol, it can't be equal to, and x just has to be less than. And we always want to put an arrow on the end of our shading to say it's going to keep going. Now you can shade like a lot if you want, or you can just show like a squiggly line that, hey, it's heading that way. But the biggest thing is we do not shade that boundary point in because it's not allowed to be equal. So now reading through this statement, x is greater than, or equal to, so we're allowed to be equal to, so I'm just going to go ahead and write this out first. X is greater than or equal to 2. 2. All right, so we draw our number line. And guys, we're always drawing a new number line for each of these situations. What is our boundary point number? Ask yourself first. Don't just wait for me. Our boundary point number is 2. We're going to draw the boundary point. If it's greater than, I'm just going to do this step by step. So if x is greater than 2, it would be this way. Right, because these are our positive or bigger numbers, so like 3, 4, 5, 6, those are all possibilities. And then or equal to, well, I'm also going to shade in the boundary point and say we could also be equal to 2. I know I got some Bengals colors going on here. Sorry, maybe next year they'll make it to the Super Bowl again. I was looking at one of my old masteries that I had written, I forget if it was last year or 2 years ago when the Bengals actually did go to the Super Bowl. I was about to fall into the habit. So then here in problem C, we want to write the inequality for what this is representing. Remember, the shaded part is our x. So we know we're going to talk about x. X, are we shading more than a number or less than a number? We're shading less than a number. Did we allow x to also be equal to the number? Yes, because that boundary point is shaded in. It is also allowed to be equal to the number. And the number that we're referencing is 2. So this would read x is less than or equal to 2, because what we've shaded is showing that x being less than or equal to 2. Guys, pause the video and take a moment to try 37 on your own with trying to like ask yourself, in this actual situation, would that boundary point be shaded or not? So a certain speed limit on a certain freeway or on certain freeways is, sorry, I just kicked my desk, is 65 miles per hour. Let x represent any speed that could get a speeding ticket. I'm going to make this red because that feels like a red sort of thing. So if we make our number line here, what is the number that we care about? The number being referenced, 65. And I normally try to put that pretty much in the middle of my number line. I haven't done this yet, but I might as well show you. You could put the numbers above the number line too. And sometimes, like, I have extra space up here, so I might as well just put it above. Always put your boundary point around that point, and then we'll go from there. Sorry, that circle got a little lopsided. So if the speed limit is 65 miles an hour, can you drive 65 miles an hour? Yes. But what we're shading is what will get you a ticket. Will driving 65 get you a ticket? No, it shouldn't. Now, I know this problem every year. As soon as we start shading this direction, somebody's going to think to themselves, now wait a minute, I know my parents go faster than 65 when they're on the highway and they don't get a ticket. Yeah, if you're lucky, if the police officer's being nice, if you're going 66, 68, like, are you really going to get a ticket if you're only a couple miles over the speed limit? Probably not. But could you, right? We're talking about could you, by what the law says, if you're going over 65 miles an hour, you can be cited for a ticket. The farther over 65 you're going, like 70, 75, 80, your ticket will be bigger. They will charge you more for the faster that you are going over that speed limit. But because 65 was our limit, we can go 65, or you could go anything under. What will get you a ticket? Anything over. You brought $10 to the mall. Let Y, now we're shading for Y, let Y represent any amount of money you could spend. Ooh, up here I forgot.
Could I please have Max carry me into the Phoenix office? Max, please go to the Phoenix office. Thank you.
What we shaded there was X being greater than 65 because that's what will get you a ticket. So down here we're going to talk about Y. The number we're going to reference is 10. And it says let Y represent any amount of money we can spend. Since we're talking about money, I'm going to go ahead and use Y. Now, can I spend more than $10? Could Y, what I spend, be more than 10? No, because I only have $10. Could I spend less than 10? Yes. So Y can be less than 10. Can I spend equal to what I brought? Yes. Y can be equal to 10. So my boundary point that I forgot to draw, so I'm just going to draw in green, is going to get shaded because I can spend 10. I'm going to shade to the left. Now, there's actually going to be another point that stops us here. I could spend $9, I could spend $8, I could spend $7. What's the least amount of money I could spend? If you want to be technical here, we could put another boundary point at 0 and say, really, I could spend $0. I could spend 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I could spend $10, but I can't really go past 0. Spending a negative amount of money would be like earning money. So unless you got a job while you were at the mall, I don't think you're going to end up like spending negative money, which would actually really be like making money. And then, sorry, I got to blow my nose. Take a second to blow your nose if you need to. Read part C. Ooh, this one gets tough. To ride your favorite roller coaster, you must be at least 5 feet tall, but less than 7 feet tall. So at least 5 feet, this is where these statements get a little tricky. So 5 feet serves as your minimum there. When we say at least 5, so I'm going to draw my number line. But we actually have 2 boundary points here. We have a boundary point at 5, and we have a boundary point at 7. So now we're going to need to ask ourselves, are we allowed to be 5 feet? You must be at least 5 feet. So since this at least says this is our minimum, we are allowed to be 5. They would let us on the coaster if we're 5 feet. That is a height that is allowed. But less than 7 feet, guys, less than means we cannot go up to 7. We have to be less than, not less than or equal to, but just less than. So we can't be 7 feet tall. Apparently they've done the math. They figured out that that would be dangerous. So we can shade all the way up to 7, but we would not shade in 7 because we're not allowed to be 7 feet tall, which I think all of us would be safe that we're not quite 7 feet tall yet. The question is, are you 5 feet tall yet? And if not, hopefully you will end up 5 feet tall to be able to ride this roller coaster. I don't think many of us need to worry about being 7 feet tall or taller. Most of us would never get that tall. All right, so that should have been enough time for about 18 minutes to review the homework using that video. And this one looks to be about 16 minutes long now. So you should technically still have maybe 5 to 10 minutes to work on your homework, which, guys, actually work on this stuff, right? Actually practice these. I'll go ahead and even start your homework with you. If we are given a problem like 42, and honestly, I think one of my next videos kind of goes over something very similar to this, I can do it on my algebra mat. So I'm going to do 42 with you, but I'm going to do it on my algebra mat. If you decide to stop the video right now, that is fine. That is up to you. So 3x minus 3. Let's get my 3x's. Now instead of minus 3, I'm going to say negative 3. All right, so there's my 3x and negative 3. And then less than, so I can pull this guy back, less than 2 and minus 2, no, wait, minus 2x. What are we going to say instead of minus 2x? That's right, we're going to say negative 2x. So there's my negative 2x's, but don't forget about our positive 2. So positive 1, positive 2. So now if I zoom out to see everything, 3x minus 3, 3x, 3 negatives, less than, positive 2, negative 2x's. Sweet. Crap. I can't do the same thing on both sides, so I don't have the same thing on both sides. I don't have any of the same thing on both sides. I don't have 1's that are the same on both sides. I don't have x's that are the same on both sides. So I think I'm going to have to start to do that whole bring stuff in sort of thing. So if I want to get rid of, and guys, I always try to deal with my x's first, especially because I don't like negativity. If I want to deal with these negative 2x's, how could I wipe out, how could I cancel out those negative 2x's? What should I bring in on both sides? Positive 2x. But I can't just do it on the right side. I have to do it on both sides. So on both sides, we're going to bring in a positive 2x. And before I do anything, I'm going to write that. I'm going to write we added 2x to both sides. That cancels out. But over here, we'll watch what happens. So these cancel out. Bye-bye. Thanks for coming. See you again next season. And now my left side has 5x's. So I'm going to go ahead and write down 5x. And I'm going to write and a negative 3 instead. Less than. Now all I have over here is 2. So then, how can I get rid of these negative 3? Well, bring in something. Guys, remember, I can't move across the fence. I can't go across this middle line. I can only bring in other values. So how do I get rid of negative 3? I bring in positive 3, but I can't just do it on one side. I have to do it on both sides. So I bring in 3 more positives over here, and I write that work out plus 3 plus 3. And now we get, well, these will cancel, all 3 with all 3. Goodbye. And now we have 5x is less than 5. Well, guys, if 5x is less than 5, what could we do to deal with, getting back to a single x? Well, guys, I can do anything, right? Anything I want. This side has 5. This side has 5. Can't I just divide? If I divide by 5, I literally split this into 5 groups. And if I split this into 5 groups, each group on the left side is an x. Each group on the right side is a 1. So really, by dividing by 5, we just only leave x and 1. So how I show that is we divide by 5. And x is less than positive 1. And that is how we solve a problem like that. All right, guys. Come see me if you have any other questions or concerns or issues with this, but that we should have had enough class time to get through all of this if you stayed focused and did what you were supposed to do. So make good choices. Please practice this stuff. The only way to learn it is by practicing it. So have a great day. And reminder, we have a quiz tomorrow. Quiz tomorrow. I keep looking at the mic even though the camera's there. Quiz tomorrow. See you guys later. Have a great day.